example, if I had 6x plus 3x, and we know that you have like terms and you can add them, and like terms with variables has to be same variable with same exponent, so that would be 9x. So if I let my number 1 problem be 6 times the square root of 7 plus 3 times the square root of 7, it's going to be 9 square root of 7s. It's kind of like, you know, you got 6 square root of 7s over here, and because remember, that's multiplication. That just means you have 6 of those, and you have 3 of those, and when you add them together, you have 9 of them. 5 square root of 3 minus square root of 3 plus 7 square root of 3. Got 5 minus, what is that? Is that 0? 1. So 5 minus 1, always understood coefficient, just like in front of an x. So 5 minus 1 is 4, and 4 plus a 7 is 11 square root of 3. Okay, to add / subtract, comma, must have same radicand. And remember, that's the number underneath the radical. So just like I can't add 5x and 3y, it's like apples and oranges. You can't add the same variables, different variables. So in this one, 4 square root of 2 minus 3 square root of 6 minus 5 square root of 2 plus square root of 6. Okay. You see some like terms? Radicand would just imply that it has to be the like terms. So we're going to put the 4 square root of 2 minus the 5 square root of 2. So 4 square root of 2 minus 5 square root of 2 would be negative 1 square root of 2. You can write negative 1 square root of 2 or just negative square root of 2. Both of them are acceptable. ACT is going to give this one. And then negative 3 square root of 6 plus 1 square root of 6 would be negative 2 square root of 6. You can commute those. Negative 2 square root of 6 minus square root of 2. Let's do 3 square root of 2 plus 5 square root of 8. And that kind of ties into lesson 19. Now, looking at them, they're not like terms because the radicands are different. But I know something about 8 from lesson 19. Can I break that down? Now, we can go over here and do it. We can do it within the problem. I think I am going to do the factor tree of the 8 over here. I'll do the upside down birthday cake. So I'll start with 8 and divide by 2. And so I've got plus 5, and I'm going to put my square root, and I'm going to put my 2 squared times 2 in there. See, because we've got the 2, a pair of 2's, and then the 2 that's left over. So I've got, I think I'll do it right here, 3 square root of 2 plus, especially for those that are quarantined, they might not be sure exactly where we got that. So we've got 3 square root of 2 plus 10 square root of 2, 13 square root of 2's. Let's multiply. Square root of 3 times square root of 6. Multiply the rational parts. Now, we mentioned a little bit, I think the other day, I can't remember whose class I mentioned it and whose I don't, but I mentioned that when you simplify a radical, you've got irrational and you've got rational. So in this case, there's an understood one outside. So you would multiply the rational parts, these two, and the irrational. Multiply the outside, I'm going to put that in quotes because that's not very mathematical, then the inside, comma, then simplify. Am I on screen? Let me slide up there. 1 times 1 is 1. Square root of 3 times square root of 6 is 18. They do have to be the same root. Square root times square root, at least in this format. You can write them a different way when you get on up in college algebra and do it a little bit different. Now with this simplify, go back to lesson 19. Will it break down? We may have even done that problem. Goes into 18 9 times. 3 goes 3 times. So I end up with, now I if you've done less than 19, I think you can handle what I'm fixing to do. The square root of 18 is the square root of 3 squared times 2. And I get to the point that I don't write that in my problem. I just go to 3 square root of 2. Is that okay with you? That if I go ahead and take the square root of this one, because that's the perfect square, and 1 times the 3 is the 3. Number 6. Let's do negative 4 square root of 8 times 2 square root of 6. Now, this is why I wrote this rule up here about do the outside, inside, and then do your simplifying. So you only have to simplify once. Let me show you what I'm talking about. See that square root of 8? You can break that down. We actually broke it down up here. But if you break it down now and multiply, you're going to have to break it down again. So why not just simplify one time? So I've got outside, negative 8. I've got inside, 48. Now, if you haven't done less than 19, you definitely want to do that one before you do this one. What about 48? 48's factor tree. Would it hurt y'all's feelings if I just put the factor tree over here? If I just go to this, negative 8 for time's sake. What if I go ahead and put, it's going to be, I tell you what I'll do. I'll do 48 equals 2 times 2 times 2 times 2 times 3. I'll do that without having to go through all the division, the birthday cake. So there's a 2 and there's a 2. So I will put in this one, the 2 squared and the 2 squared and the 3. I really think you need that step. I need to see it. The ones I've graded have done a good job setting theirs up. So there's a negative 8 on the outside. This square root of 4 is going to come out. This square root of 4 is going to come out. And that irrational square root of 3 is going to stay inside. You have negative 32 square root of 3. Page 47. Okay, remember the other day we did the idea that the square root of like 7 squared was 7? Keep that in mind because I think that's going to help you on this one. If I have, look at how this is written. It's square root of 5 in parentheses squared, like that. Square root of 5 squared mean square root of 5 times square root of 5. Everybody good with that? Okay. Now that is actually the same as the square root of 5 squared, which is, and most of you are going to think it that way, square root of 25, which is 5. But that's that same idea that if you are taking the square root of a perfect square, it's going to be that number. That's what ends up being. So that's kind of a neat little feature there to help you, especially if it's like we did the other day, 50 squared or 52 squared, where you don't have to always punch the keys on your calculator. Just a little extra note there. Number 8. So do the same thing with 3 squared of 6. Now we do this later on in the Pythagorean theorem pretty soon. And people struggle with this one. But if you know how to multiply like 5 and 6, I think you can handle it. It all comes down to what squaring means. That's 3 squared of 6 times 3 squared of 6. What's the outside? 9. What's the inside? 36. Is that a perfect square? Yes, and it will, because square root of 6 times square root of 6 is a square root of 6 squared. So that's 9 times 6. And at some point, you may get to the point that you could skip that step, and that's 54. One last one. Let's do 3 square root of 12 times negative square root of 12. Your outsides. 3 times negative 1 is negative 3. The square root of, and again, if you would think of it as, oh, well, that's 12 squared. So that, you know, like that was a 57 and a 57, do I really have to square it? I'm going to write it that way. You know, if you need to write it as 144, you're good. It's negative 3 times 12, and you can still think of that as 144. You know, we're good with that, and the answer is negative 36.